Welcome students. Today we will discuss about the estimation of distribution algorithms. EDA algorithms, they are stochastic in nature. They are belonging to stochastic optimization algorithms. That means you will explore the candidate solutions with the help of probabilistic models. Let me write algorithms. In this EDA algorithms, we will explore the candidate solutions by sampling the probabilistic model. So that means here we will explore the candidate solution space by sampling the probabilistic model. This probabilistic model is constructed again from the best solutions. You can see this probabilistic model is constructed from the best solutions in the current population. So this is how the algorithm works. So that means you will start working with a population of candidate solutions, and then you will construct a probabilistic model with the help of current generation, and once probabilistic model is designed for the current generation, we will sample the probabilistic model to get new population. Likewise, these two steps are repeated until you reach the termination criteria. Okay, this is how the algorithm works. We will explain with the help of one example. So here there is some additional parameters that are defined. Selection operator, which is denoted as T 50%, or this is a hyperparameter 50%, or like this. Now let us take one example so that you will better understand what is happening. What is happening in this? Let us see. So let us take a fitness function. Let us take one example, illustrative example. Let us take the function as simple summation of n variables. This is our function, and let us assume the xi it is a binary variable, 0 or 1, or you can tell as 0 or 1. That means a binary variable. Here n is the dimensionality of the solution vector, or you can say as a number of variables also. So let us define another parameter, the population size. I already told you EDA algorithm is also belonging to population based search algorithm. So let us define the population size as n. N is equal to 6, and the dimensionality d or small n. The dimensionality or number of variables. Number of variables is for simplicity is, let us assume I am taking 5 variables. So the dimensionality of the feature vector is also 5. Okay, let us first start the process, and we have to define another parameter. I already told you, threshold or selection threshold. You can write selection threshold. For simplicity I am taking 0.5, or you can take as a 50%. Okay, that means 50% solutions are taken, 50% solutions are rejected for constructing the probabilistic model. So actually here we are going to find out a simple maximization problem. This is a summation of variables. Maximization. Once you understood, it is very easy. So this algorithm also starts with initialization of population. Initial population. We have defined the population size as 6. So by random sampling, let us assume the first sample is 0, 1, 0, 0. So and its corresponding fitness value is, so here the fitness value is obtained by substituting the binary values into this equation, fitness function, and you will get 3. One, let us sample, and if you get binary value and its corresponding fitness value is 4, 0, 1, 0, 1, 0, and its corresponding fitness value is 2. Let us sample another value 1, 0, 1, 1, 1. I am randomly sampling, and its corresponding fitness value is 4. So 4 ones are there. 1. Let us sample 1, 1, 0, 0, 1, 0. Let us, this is the 6th sample we are taking in the initial population. So clearly the fitness value is 2. Now the next step is selection of parents. I already told you the selection threshold is 0.5, or you can say as a 50%. So what you have to do means select the 50% of population. Here the population size is n is equal to 6. N is equal to 6 means out of 6, what is a 50% of the 6 samples? So 3 populations. So select the best 3 populations. So clearly, since it is a maximization problem, select the top 3 solutions having high fitness value. So clearly this is having high value, and this is having high value, and 3 is also having high value. Corresponding to that, you select the 50% solution in the current population. Okay, so the selected solution is 0, 1, 0, 1, 1, and then this is also selected 1, 1, 0, 1, 1. This is this solution is rejected, and this solution is selected because it is having maximum value 1, 0, 1, 1, 1. So we already got 3 members in the population. So remaining all you can neglect. Fortunately, all those other members are also having very less fitness value. So this is the fitness as per the fitness function, fitness value, we have selected a elite population or elite solutions. So the next thing is you need to construct the probability model. Construct the model, probabilistic model. So for each variable you have to construct a model. So how many variables are there? 5 variables. Let us probability. So here in this example we are showing a very simple example. So here we are directly finding the probability vector. So for first variable, you can see this, I will write in red color so that you will understand more clearly. You can see, you take the for first variable, how many ones are there? So 2 ones are there out of 3 solutions. So the probability of being 1 is, for first variable is 2 by 3. Similarly, the probability of x2 variable, this is x1 variable, x2 variable, x3, x4, x5. The probability of x2 variable taking 1 is 2 by 3. Similarly, the probability of x3 taking 1 is 1 by 3. The probability of x4 taking 1 value is, it is 1, all ones are there, you can see this, x4 is 1. Similarly, for the probability of variable x5 taking 1 value is again 1. So let us, this is our probability vector. So let us write more clearly, 0.6, 0.6, 1 minute, my cursor is not moving, so I am selecting my cursor, now it is okay. 0.6, again 0.6, 0.3, 1, 1. Now with the help of this probability vector, you perform the sampling again to get new population. Okay, now you got our probability vector, probability model as 0.6, 0.6, 0.3 and 1 and 1. Now with this you perform sampling with the help of this probability value to generate new population. So it is a simple 1 or 0 means, so you randomly sample the values based on the probability value. Let us assume you will get 1, 0, 1, 1, and again you sample with the help of this one, 1, 1, 1, 1, 1, and the corresponding fitness value is 3, corresponding fitness value is 5, and again let us sample another value. Since the population size is n is 6, you have to sample 6 times. For each variable you have to perform sampling 6 times. So again you sample it, if you get like this, you will just, I am randomly writing 0, 1, 0 and 1, 0, 1, 1, 1, similarly 0, 1, 0, 1, 1. So we have sampled 5 times, last time we have to sample, let us assume the sample value is 1, 0, 1, 1, so like this. So in this way we will generate new population with the help of elite solutions. So for generating new population, P2 from P1 means you have to select 50% best solutions. So you can just select this one, this is having high value, this is also having high value. So likewise you have to repeat the steps again and again until you reach the stopping criteria. So you can clearly see from this example, we have selected three solutions. So selected like this. Selected, what are the selected solutions? 1 1 1 1 1, and similarly 1 0 1 1 1 1 1 0 1 1. So once solutions are, again you have to construct the model. You have to construct the probabilistic model. So let us calculate. So the probability of x1 variable, x2 variable, x3, x4, x5 variable 1 is, it is 1, x2 variable is 2 by 3, x3 variable being 1 is 2 by 3. You can see this, x3 is, x4 is 1 and x5 is 1. So again you have to repeat the same steps again and again. It's all about selecting the best solution and constructing the probabilistic model, and again perform the sampling. These steps are repeated until you reach the termination criteria. So at the final population you will get, it is assumed to get the good optimum solution. This is how the algorithm works. This is how the algorithm works to obtain best solution. Okay. So let us write one algorithm regarding this, detailing the process, what is happening. Algorithm, EDA algorithm in short. You can make improvisations also. So let us write the stepwise. What are the inputs for this algorithm? Inputs are fitness function and control list parameters. So in this control list parameters you can specify the maximum number of iterations and the distribution function, selection probability T, and selection probability T you can also select. These are the things you can select. Any other things are the probabilistic model. What type of probabilistic model you have to model, that also you can pass it as a control list parameter. Second step is initialization with the help of control list parameters. Third step is you can generate a local optimization also. So this is just an improvised version. You can also, given a population, you can perform local optimization with the help of given current population and fitness value and control list parameters, and then you can choose the best, store the best solution basing on the fitness value and the current population P, and you can take one iteration variable. And next one is, now we will enter the loop while termination criteria is reached given current population, fitness and control list parameters, and then you select the parents from the current population. Let us term as P dash. This step 7 is all about selection of parents. Okay, selection of parents are selecting the solution, selecting the parents, or you can say whatever it is. Just I am naming P, F, C. We have already defined the parameter na T. T is also there in the C control list. So parents are selected or solutions are selected, and afterwards you can learn that means train the probabilistic model with the help of those parents, and you will get the model M. Let us denote as M. Once you learned the model, once you got the model, you perform the sampling process, sampling given the model, and you get new population. Let us term as P dash. This is new population. So we are not, once we got new population, if required for better thing, you can send it to some local optimization algorithm like hill climbing or simulated annealing. You can call, you can pass to P dash FC, and you can get again P dash new population, and afterwards once you can perform local optimization, you can choose the best one. This is for output display purpose. Okay, given B and new population and the fitness value, you can choose the best one, best solution as a optimum solution. Here B refers to, always B refers to, you can write here, B means optimum solution. Okay, after that, so finally you can create we have created a new population. Finally we create a new population. Okay, or you can compare with the old population, and for that you can call one function called as a replacement function, where you will compare all the solutions in the current generation and the new generation, P and P dash, and select the best solution and store it in the next generation. And finally you will update the loop variable. You can update the loop variable I plus 1, and finally you can stop end while loop. So after running for maximum number of iterations, you will get the last output in the form of B, which contains the optimum solution, and P is the last population, last population. So here in the local optimization, you can see in this you can use hill climbing or simulated annealing or tabu search algorithms. You can use any of these algorithm to get a better solution or better optimal solutions. So these are the common steps involved in this. I hope you understood, students. Thank you.